Hello, this video will help you guys in implementation of circular buffer. Our processor has a special purpose hardware for implementation of circular buffer. So step number 1 is to tell processor by writing 1 to AR1LC that we want to implement circular buffer. In step 2, it's for circular buffer implementation, store filter length in register BK03. Store starting address of input of an input array in BSA01 register. And then AR1 register works as index or offset for circular buffer. If you write this instruction, move star AR6, which is pointer to our input data, star AR1, which we are using it as a offset for circular buffer. Processor will consider this as star AR1 plus BSA01. So use AR1 as index of circular buffer. We'll take a short example. Suppose we want to implement four element filter, filter of length 4. Then, and this is an input 4 length input array. Then FIR buff will contain starting address of our input array, which has to be stored in BSA01 register hash FIR buff. We are using hash since it is an immediate value, so compiler needs to know whether it is immediate value or some constant like that. And then BK03 will contain length of buffer, which is 4 in this case. And declare and after this declare variable old index, like we do it in C, like int old index is equal to 0 and initialize it to 0. So in assembly you write it as an old index dot word and value with which you want to initialize your variable. So it has already been done in your skeleton code. So refer your skeleton code for that. Then move old index value to AR1 register using this statement, move star of hash of old index comma AR1. Please remember that old index word stores it is a address of a memory location from which we want to copy something to AR1 register. And after you are done with this step, write input to circular buffer using move star of AR6 comma star of AR1. And after this step, uh, store value of AR1 to old index so that value of old index remains intact in next call of circular buff function call, which is being called from main.c file. And finally implement mac operation. Point to remember in the circular buffer is that when in circular buffer mode with above discussed settings, if we keep on increasing AR1 value, and in boundary cases when AR1 is equal to VK03, this register stores length of our buffer, AR1 is automatically resetted to 0 by hardware. So don't worry about boundary conditions. We don't need to check whether our old index value has reached to a boundary or not. It will automatically be implemented in circular fashion by hardware. Then if you for more help in this topic, you can open CCS 3.1, not 4.1. Then go to help, go to index and search for circular buffer implementation. So you will know whether various ways of implementing circular buffer. And if you don't have CCS 3.1 installed on your system, then obviously ask Google Baba. Thanks.